Hi, welcome back. In this video, we're going to learn about orthogonal matrices. So the definition of an orthogonal matrix is an invertible matrix, A, such that the inverse of A is equal to the transpose of A. So let's check a specific matrix. So let's let A be the 2 by 2 matrix, 1 over square root of 2, negative 1 over square root of 2, negative 1 over square root of 2, negative 1 over square root of 2. So I don't need to actually check and find the inverse of A. All I need to do is write down the transpose of A and then see if it turns out to also be the inverse. So remember, the transpose of A is just the new 2 by 2 matrix we get by making the rows of A into the columns of its transpose. So if I write down A transpose, it turns out in this particular case that A transpose is the same as A. So now, if I want to check and see if A transpose is actually A inverse, all I have to do is multiply A times A transpose. So let's do that. So writing down A and writing down A transpose, which happens to be the same matrix, and then multiplying those two. Remember how we multiply two matrices, so the entries in the first row of the first matrix times the corresponding entries in the first column of the second matrix will give me the first entry in the first row, first column of our product. So we ended up here with 1/2 plus 1/2. And then we do the same thing for the first row, second column. We'll multiply the corresponding entries of the first row of the first matrix with the second column, the entries in the second column of the second matrix. And there we get negative 1/2 plus 1/2. And then we do that again, same procedure in the second row. So in the second row, I'll get negative 1/2 plus 1/2, and then the second entry will be positive 1/2 plus 1/2. And then when we simplify, we get 1, 0, 0, 1, which is in fact the 2 by 2 identity matrix. So we've just shown that A inverse is A transpose, and that means that our matrix A is orthogonal. All right, you know where I'll see you. I'll see you in the next video.